Good day, everybody. Today, my name is YUNUSOV TIMUR, and me and my colleague Alexey Osipov are going to tell you how to get full access to your 3G or 4G devices and do it only by SMS. We are part of the SCADA Strangelove team, and this research took many times, half of a year, and there were many people who involved into this research, not only we. They are on the slide. Thank you, guys. In this research, we speak about 3G, 4G network. 3G, 4G network is really very complex and big thing. That's why in this research we speak only about access level and about access level devices. These devices like phones, smartphones, femtocells, USB modems, USB routers, of course about the SIM cards, and we'll speak not only about the traditional radio access but also about IP access and IP access problems. And this research is done not only because we use 3G, 4G networks every day for social network, for hacking stuff and so on, but also banking, government, industrial companies use the 3G, 4G networks every day, and it is the scariest part. Radio part is really well researched. At this moment, there were very cool research of these people like Karsten Noll, Alexander Chimezis, and so on. Their research are great. Thank you, guys. We will speak about the IP network, IP access, and about this device, GGSN. GGSN is something like final point which provide access to the internet from the telecom, and if this final point and view to the internet also can be accessed from the internet, and they are. If you look in Shodan for words like GGSN or words like GGSN model names like Alcatel-Lucent, you can find really many devices which can be accessed from the internet. And next possibility is to look for specific GTP ports, TCP or UDP, and send the specific GTP requests and wait for specific GTP responses. And that's how we found these devices all over the world, from Russia and China to USA and Canada. What's the problem here? Problem is about if you get IP address of GGSN device. First of all, you can look for the specific management ports like SSH, Telnet, get access to them and get inside of telecom network. Next problem, if you compromised one GGSN, you can attack other GGSNs and other telecoms with GPRS roaming exchange protocol. You can attack GTP protocols, GTP applications, and get the denial of service, or steal some private information, or steal some monies and get the fraud, or you can get inside of some private APNs. Here is an example of attack very similar to TCP SYN flute denial of service, but only at the GTP level. hacker sends millions and millions PDP context activations requests to the GGSN, and in some moment pool of free requests is finished, and the next customers which try to get access to the internet from their phones simply cannot get access to them. Next surface of attack is when you are inside of telecoms network. For example, if you are a simple subscriber. First of all, you can get the internet, try to use traceroute to some external port, see some internal IP addresses in traceroute table, and try to get access to them by some management ports, HTTP or IPv6 or UDP or some specific telecoms protocols like GTP and so on. And that's how we found this device. Also GGSN, also very big, also very expensive. Problem of this device was that it gave us, without any authorization, private APNs names. What does it mean? It means that if you know the private APN name, you can change your APN name in your phone and get access inside of some private network, like banking network and or government. And something like hello from 90s, when your balance is negative, you still can get access to the internet by UDP requests with DNS tunneling and so on. Internet providers fixed these vulnerabilities maybe 10, 20 years ago, but they are still present in mobile telecoms. So what can we recommend for telecoms? Of course, you should know what your devices could be accessed from the internet. You should not forget that your subscribers' network are not your own trusted network. For auditors, if you check all the states when you are with negative balance, when you are in roaming, when you are in different subscriber plans and so on, the results may surprise you. But you should not forget, you cannot hack other subscribers. It's illegal. Next part is about the devices, about 3G and 4G USB modems. 3G, 4G modem, it is not only black box that you plug into your computer to get the internet. It is a small computer with operation system, file system, with Linux or Android on board, which support many interfaces like SD cards, virtual CD-ROM, management COM ports, and so on. And of course, network part, like remote network devices and sometimes Wi-Fi. These parts are also really well researched. First of all, people research firmwares of 3G, 4G modems from this point of view, like how to update the firmware, how to customize the firmware or web dashboard, how to unlock the device, and so on and so on. But there were also some security researches in last years, like in last year were found 2 vulnerabilities in Huawei modems. There were presentations of Nikita Tarakanov about the Huawei modems problems and so on. But most of them have only local impact, and we were tried to get the remote impact. And here is the developers of modems that we looked into, but you should understand that not all vulnerabilities belongs to these firms, because every telecom company write their own firmwares, dashboards with their own vulnerabilities, and so on. And the security paths are also well known. Let's disable all the interfaces, all diagnostic ports, leave only one web dashboard with one button, connect to the internet, but as you will see, it's pretty enough to hack the modem. What happens when I plug in a device with network interface to the computer? It gives me new interface, a new IP address with, by the HCP server on the modem side, write some DNS records, open the web dashboard, and where pressed connect to the internet, make a route from my computer to the internet through the telecoms network. And when I see new IP address, first of all, I will scan it for open ports. That's how sometimes you may find something interesting like open diagnostic telnet, and if you are lucky, you can also find root password and get full access to the device. But it's not so funny, first of all, because sometimes you found nothing if modem is not so popular. And next problem is about that you cannot exploit telnet vulnerabilities remotely with browser, with client's browser. That's why we decide to look into the web server's vulnerabilities that we can exploit remotely. First of all, because almost all web servers simply do not have some protection like CSRF tokens and so on. And next, we will tell you also about how to attack the broadband part. Vulnerabilities, we found many in every modems, from the information leakage of current base station ID to the client-side vulnerabilities like cross-site scripting, cross-site request forgery, and so on. Also vulnerabilities about authentication bypass, like when your PIN code is on and open page with entering of PIN code, you still can hide this window just and get access, for example, to file system, to SD card, to Wi-Fi. Then you, of course, with client-side vulnerabilities, you can change the DNS servers to intercept the traffic. You can read and write the SMSs, send USSD requests, read the contacts, and also look around the device with Wi-Fi scanning, for example. Next interesting part was about vector, how to get access to self-service portal with SMS. You send XSS with SMS, pound the browser of subscriber, then send USSD request to reset the password, intercept them with XSS, and get access to self-service portal. Also, very simple denial of service attack when you send 3 requests with invalid PIN to this window. Then you send 10 invalid unlock codes and make a brick from the SIM card. Or you simply can change the IP settings and also brick the device. And finally, in the last couple of months, we use the devices and remote code execution on these devices to turn them to the spy devices. And here is first video. About how to get full access or how to get access to the self-service portal by SMS. Here is vulnerable page. Vulnerable page of SMSs. Here is my phone. I sent XSS by SMS, and some moment it receives, sorry. You need to update the page to inject the code. If you see the source code, you can find link to our injected code. Next, we have some console, hacker's console in another browser, which get the command, receive the data about modem infection. Just a moment. Here it is. Then we reset the password by USSD request, get the new password. Of course, this SMS we can hide, and send the password to the hacker to get access to self-service portal. It works transparently to the client in background. And then we can delete the SMSs and steal all the data. Okay, next problem is about all modems have firmware updating page. Some modems just hide them in comments. Some modems have some protection, like CRC16. Some modems have protection with crypto functions, but we still can delete this crypto function script and bypass the checking. Next problem, you need to get the original firmware to upload your vulnerable code and reverse them. But you should not forget that most of all web servers on the modems, it's simple CGI, which get the data from the HTTP requests and send them directly to the shell without any checking. That's why you can find remote code execution almost everywhere, in content length header, in post and get, and so on. And of course, if you cannot exploit remotely content length head, you still can exploit post data, post forms and post parameters. Now we get access to the modem, get the remote code execution. What's next? Here is an example, as I said, how to get your own, make your own SPICE device from the modem. You can, there were one telecom in Russia. They give us a modem for 1 week for testing. Then we can back them to the store. You can get the modem. You can use the remote code execution remotely, or infect the local modem, infect the system, and with script which send current cellular ID base station by DNS every minute or every 5 minutes. Then you can intercept HTTP, HTTPS with DNS spoofing, and intercept the SMSs if you have a remote code execution. And that's how I walking from my home to my work in Moscow with this device in pocket, switched on. But you should not forget, once again, do not hack other subscribers. We asked ourselves how many modems were vulnerable, and used the script on some security portal in Russia to gather the data with image recognizing. For 1 week, we found more than 4,000 vulnerable devices, and for 1 or 2 requests, we can switch these statistics, just passive statistics, to active vulnerable and remote infection modems remotely. Okay, we can change the firmwares. We can attack the clients by SMSs, by USSD, with cross-site scripting, cross-site request forgery, and so on. Then we decide to pound the subscriber. First vector was if you have remote code execution, you can update the virtual CD-ROM content and infect the host with virtual CD-ROM and installing the malware with installing the diagnostic tool. But more obvious part is about making from your USB modem bad USB modem, like Carson said. USB have, as you may know, USB have master-slave architecture. Drivers are also split to the device-based drivers and to the host-based drivers. There were not so much problems with host-based drivers. They are standardized and universal. Let's speak about the device-based drivers or gadgets in Linux terminology. One device may have different interfaces, and there is composite driver framework for these devices. As I said, many modems work on Android kernel. In Android kernel, we have Android gadget driver. Very interesting gadget. This driver is something like a wrapper around composite driver framework, which provide you interfaces and utils to change the behavior of the modem in runtime without restarting and kernel patching. That's how your phone can become SD card or audio source and so on. Here is proof of concept available on the Google Play. It makes USB keyboard from your tablet, but it is very sad proof of concept. First of all, it needs root access, then it needs kernel patching, supports 2.5 maybe devices. That's why it's sad. We decided to make our own bad USB driver for modems. All you need is to find supported functions array in runtime, patch them by adding new human interface device function to this array, restart the device, and get the profit. But in real world, we of course met some problems. First of all, Linux kernel do not have human interface device gadgets by default. That's why we need to take them on board. Then there were problems with creating universal human interface device driver for arbitrary modem. It is problems with version signatures, with changing prototypes and structures of export functions. Problems, of course, with different hardware. It all just means that you need to fingerprint the device before invasion. It is very big and hard work, but if you were good enough, you will get something like that. Here is already infected vulnerable USB modem. Plug into the computer. Get the new remote network device. which opens the browser by default. Then it's hide, reboot, and here is human interface device keyboard appears. And then some magic without any hands, which enter in the commands like calc, or you can read the BIOS for loading from the USB stick. Then you can restart the computer. Sorry. I'm sorry. Let's start again. As I said, here is vulnerable device. With remote network interface. Here is keyboard. After restarting, and predefined commands to launch the calc, read the BIOS data, restart the device, and load booting from the USB storage to infect the computer. Here it is load from the bootkit. And next demo about more obvious path. Plug out the device, plug in the device, and get the kernel panic. And last couple of months, we interested in this device. It's some Huawei modem with high silicon chipset, Linux on board, which have some different one-day vulnerabilities. It's not the latest firmware, maybe, but we found also Stack Overflow and possibility to upload the firmware remotely. But this is not the point. Point is about someday my colleague found some interesting stuff about that Linux on Huawei load VxWorks operating system, which works on baseband process and work with radio part. There were many problems like ACN1 documentations, 3GPP documentations, problems with working in real-time operation system. All debugging was hard. But resume that Linux operation system, load VxWorks operation system, image by in well-known base address. You can update, that's why you can update, debug, and so on the VxWorks image. WixWorks have C shell, something like operation system shell for some commands, have well-documented objects and functions. That's why you can reverse the WixWorks code almost to the C-like code. And with these possibilities, we get the vector attack to attack baseband. We call them Osmocom for poor people. Okay, so for telecoms, we recommend not try to reinvent your own web server. For everybody, do not plug in the device into your modem. Okay, thank you. Questions?
Actually, we have some problem because we told that there is no time for the last part of the presentation. Then I shall continue if I may. Every device that already mentioned by Timur have a small piece of plastic called SIM card. And the SIM card is essentially for the customer is something that is used for just connecting to the mobile network and that's it. But for a hacker, it's own device. It's a microcontroller with operation system, with its own file system, with applications on it, which allows you to access the network, to manage keys, and do very different things. On our SIM cards, there is applications. For example, when you plug in SIM card in your phone, there is a menu where you can access different products from your operator. For example, different applications for managing your telecom contract and so on. Every such application have its own toolkit application reference, or TAR. For hacker, not all applications are equally secure. For example, applications that allow you to upload firmware on your SIM card is protected more thoroughly than the application which allows you to only to send SMSs for some numbers. So if you are but every application is protected by its own cryptographic key, and if you're lucky enough, you can find something to brute force it, because these SIM cards are actually made from the 90s and they have death encryption in it with 56-bit keys to protect. There are different opportunities for brute forcing. For example, you have rainbow tables for predefined applications. But actually, it's not the case if you have no time for all different applications on the SIM card. So you can just build something new to brute force it. You have video cards, you have CPUs, and after the Bitcoin, there are plenty of devices that are already there for brute forcing. It's FPGAs. So we bought from the eBay some of them, and there is 8 FPGAs that cost you for about 2,000 euros. We managed to make it into brute forcing device and seen what opportunities it gave to us. For example, Radeon R290 gives you 3,000 million crypts per second. Our device is about 100 times faster. You have keys for the application, but what actually you want to see in this SIM card? You can send different commands. It's a bit of fuzzing, where you send something and get different replies. But there is actually predefined applications, for example, card manager that allows you to reprogram your SIM card, or file system applications that allow you to access remotely your information on the SIM card. Card manager is the holy grail. If you can reprogram your SIM card, you can get access to cryptographic keys, you can clone your device, and do whatever you want. But there is actually no successful proof of concept for this, so we managed to access file system. On the file system, you have not all cryptographic keys, but only session ones. They are protected with the PIN code. It's a 4-digit number that allows you to access it. Most of the SIM cards on your phones are not protected with it because it's quite obvious that you can protect it by swiping the iPhone unblock code or Android code and so on. There is no need for another protection. But for accessing from the telecom network for this SIM card, you should have cryptographic keys or PIN code. There is no fun sending it locally, so you can take Osmocom phone and send SMSs to arbitrary number on the telecom network. If you don't have Osmocom, you have opportunity with SMS centers that allows you to send such binary SMSs to any number. Binary SMSs can be filtered, but actually it's not the case for different operators. There is different opportunities. For example, intra-network communications, inter-network communications, SMS gates. And if it's everything wrong, you can just use fake BTSs or femtocells to gain access to the phone directly. The access conditions, as I already said, is PIN code, and often operators set the PIN code with 4 zeros, and it's actually easy to brute force many number of phones with the default PIN code than to brute force one device with many PIN codes. And it's an obvious way to block all devices, so we can just send 13 SMSs and to enter wrong PIN code and block your device. But there is a different opportunity. You can access current cipher keys and current identification number to clone your device from all over the world. And the great problem is that all operators are I think that it's too hard to do and just ignore you. I will show small video, and this will be all. On the left, we have Osmocom phone with this console. We access mobile, and we're accessing the telnet connection to it. On the right, we have Nokia smartphone and iPhone. We are sending SMS from Osmocom to the iPhone to see that it's Osmocom device. Then we send binary SMS to Nokia phone that gives us a cryptographic key from it, and we're sending binary SMS to get identification number from it. So it's obvious that if older devices are not protected from these attacks, newer devices are also unprotected because these binary SMSs are not protected with the operating system, but directly connected to the baseband of the phone. So we're sending the from Osmocom SMS to the iPhone and see that it's not from the previous number, but from the new one. That's it. Thank you.